Oh,
Hello?
no.
Now,
Oh, sorry. Can you guys hear me now?
Your other device has to be muted. Like, I don't know why.
Yeah, just give me 1 second. Is it better now?
Yeah.
I apologize. I thought I wasn't on mute. But let me start over. So, hi everyone. So, thank you for joining us today. This is sort of our third session on engineering entertainment. And today we are learning about lenses and cameras. And today I'll be delivering your session on it. So if you don't know who I am, my name is Nicole and I am the Engineering Outreach Program Instructor. You've probably heard about me through your emails. I've been the one who's emailing you about sort of the programs that we have, the live learning sessions, giving you reminders on sort of what to bring and prepare before our sessions today. But a little bit about me is that I did a degree on biomedical engineering. Does anyone remember what biomedical engineering is? Of sort of what biomedical engineers do. It's sort of related to the word biology. If not, biomedical engineers sort of work in healthcare. They solve problems related to medical equipment, and that's sort of the field that I do. Yeah, Nathan, Jason, it's all related to medicine, biology, and how we can help humans and their health. So you probably know about a code of conduct, but just to sort of repeat it. So join in the Zoom session with your first and last name. As we are on our YouTube channel, we are live. So for your privacy, you would try to keep your microphones and cameras mute and off. And if you want to interact or ask any questions, you can use the chat function on Zoom, as you can see on this image here. Let's keep a promise to be respectful for everyone in the virtual classroom. Everyone has a right and a sort of responsibility to sort of promote that sort of safe environment for everyone to learn in this session. As a sort of disclaimer, as I mentioned, we're being live streamed onto our YouTube channel. The focus is going to be on me as your facilitator, and you're not required to turn on your camera audio unless you would want to. And consent was to be filmed was already completed during the registration process. So we've seen this a lot before: science, technology, engineering, and math. And just to quickly go over it, so science is sort of understanding the world around us through experiments. So I like to think about science as sort of just a circle like the earth, and it's filled with human knowledge that humans have learned through the history of mankind. And what sort of scientists and researchers like to do is sort of try to expand that circle, even if it's just like a tiny bump from like an observation they found, an experiment they did, whether it worked or it didn't work. That sort of bump of knowledge that we've learned is sort of useful and will help us in future generations and makes our lives even better by just knowing that knowledge. And yeah, Nathan, Jason, STEM is solving problems around us using science, engineering, tech, and math. Yeah, all four of these areas contribute to each other one way or another. Technology is sort of those tools and machines that helps us solve these problems. It doesn't have to, even though it has the word technology, it doesn't just have to be sort of like your cell phone or your computers. It could be sort of non-electrical equipment such as a drill, a hammer, just helping us make things up. And that's where engineering sort of comes in. So they use sort of science, technology, and math to sort of solve real world issues, help make society a better place by designing and building models. And to do that, they might be using math. So being able to understand those numbers, those shapes, those patterns that math has around in order to understand the world. Oops. So this entire season is all about engineering and entertainment, and we're really trying to see how engineers play a big role in sort of the film industry, in sort of creating theme parks, creating those kind of performances on stage. And we've seen it in the past two episodes where we're talking about sort of animation and we were making kaleidoscopes. And a lot of different engineering fields play a role in entertainment engineering, but these are sort of the six that I think sort of play a bigger role, sort of mechanical engineering, material science engineering, chemical engineering, aerospace engineering, computer engineering, electrical engineering. And we've sort of explored some of these in the past two sessions, and we're going to explore one into greater detail today. So does anyone know about what optical engineering is? I'll give you a sort of a clue. It's sort of like a special type of electrical engineer. And we've actually learned about this in our previous session in kaleidoscopes. Yes, Sean, lenses, Nathan and Jason say lenses. Yes, it's related to lenses and optics, which really which comes from the phrase about learning about the eye. So what do you think sort of optical engineers create? Yeah, like Hakim Optical, they sell lenses for us and engineers design those lenses. Cameras, that's a good point, and that's what we're sort of learning today. That's sort of a good hint to what optical engineering is. So the optics really is about studying light and how it behaves. And so optical engineers sort of analyze that. And from there, they just sort of invent, design, build, and test devices that make light do something useful. So you see how the connection of science and engineering is? So like in science, we have a lot of knowledge about what light is, and engineers take that knowledge and sort of apply it to see, how do I make light sort of very useful? And they do that making these devices while sort of considering different things like making sure those devices are cheap, they're safe to use, especially with light, as it can be very dangerous, and sort of the available technology. Can sort of anyone come up with examples of what those devices are to make light useful? Some of you said lenses, some of you said phone screens, cameras. Does anyone have any other examples? It's a lot about seeing things and sort of how light can allow us to see things. So it could be things such as, yeah, screens on devices, on your phones. Optical engineers play sort of a role on that. They can design lasers. Lasers are made out of very strong light rays that are sort of focused together. Prisms are a good example. And another example would be telescopes, like view planets and stars and everything about our solar system. Great job, guys. You guys know what an optical engineer does. And sort of these optical engineers sort of play a big role in sort of the entertainment industry. So I'm not sure if you know about this, but lighting in film, it plays a huge role in film. It's a very tiny detail that you don't really notice maybe in when you're watching a movie, but they do play a role in telling a story. It helps sort of create that sort of vision, sort of a mood or atmosphere or sense of meaning for the audience, whether it's sort of helping an actor be more focused or sort of try to highlight something on the stage. Lighting can play a huge role. So over here in this first image over here, you can see that film plays a role in sort of acting as a guide. It tells like where people to look at. Yeah, silhouette. Like you can see that sort of contrast between the background and the person over here. It helps us guide and make us focus on them maybe interacting, or it sort of conveys that sort of atmosphere. Does anyone know what kind of film genre this is? It's a sort of very specific type of film genre, and it's in the past. Horror is a good guess. Mystery. Yeah, it's sort of related to sort of mystery, but horror is actually a good, can probably be sort of incorporated or mixed in here. So this is sort of a very old film style. I think it's around, they used to make it a lot in the 1920s or to 1950s. So maybe like 80 to 90 years ago when color wasn't really invented on screen. So this is sort of a film genre called film noir. And yeah, Nathan, Jason, it's sort of crime mysteries, detectives, a lot of those action crime dramas use a lot of lighting to create that sort of black and white sort of setting or atmosphere to create sort of that mystery or sense. And also lighting can create sort of and highlight different moods. So as you can see here, we normally associate red with like something that's angry or mad or crazy or dark or sort of evil. And when you put that evil sort of red lighting onto, I guess, this bird, it sort of reflects that he is laughing manically and sort of is feeling sort of being angry. I think this is from an Angry Birds film. And as you can see here, like that very harsh red light sort of just evokes that that bird is probably evil. And it's sort of a similar example here, can convey atmosphere. So I think this is Big Hero 6. Yeah, Jason, Nathan Jason, it evokes anger. So this is, I think, Big Hero 6, Baymax. As you can see in the before and after pictures, in the before pictures, if you didn't have any lighting effects, it can be sort of a gloomy or sad scene. And just having sort of white or bright light, which we normally associated with like nice, happiness, sunshine, it makes that sort of film seem more warm, like as they're hugging. It makes it us feel like we're part of it. And that's what lighting does. It sort of defines that genre or atmosphere and tells this what it helps us as an audience or a viewer what we want to see. Yeah, this movie is awesome. It's one of my favorites. So last episode, we learned about light, and light is sort of that form of energy that sort of travels in a wave as a sort of straight line, and it travels very much faster than sound. And Jason already guessed this. Yes, this entire demonstration over here is sort of refraction. And refraction is sort of the change of direction in light when it passes from one medium to another. So as you can see in the beginning, light is traveling from the air and it goes into sort of this other medium, like a liquid. I think this is sort of water that's sort of colored. And as you can see here, as it passes through that other medium, it sort of bends and the light sort of refracts from one way to another. And this is sort of what we're going to be exploring today. Last week in our episode, we learned about kaleidoscopes and reflection. And here we're going to look at refraction and sort of how it plays a role in sort of lenses. But beforehand, everyone knows about the engineering design process, and it's very important for engineers to follow this process to make sure that we have a good final product that is sort of well created. It's important for engineers to, yeah, Nathan and Jason, identify the problem. We need to make sure that we know what we want to do. We want to brainstorm ideas, creatively think about it, think about what potential solutions are there to help solve that problem that we have. Next, we have designing a solution. So coming up and sort of making that solution a bit better, trying to get a good concrete idea of what we want to create. And as Jason's suggestion, we want to create that model. So start prototyping it, start building a model of what our design should look like. And we want to see at the end, we want to test and evaluate it as we want to make sure that this product works. And we don't just stop here in this cycle. Once we do test and evaluate, we go back to either the previous step before that, the previous step before that, or even just into the beginning. Like the engineering design process is very iterative, and we want to go back to the steps as many times as possible until we are confident that our product will work to meet the problem. So as I mentioned before, we are talking about lenses and optics is sort of the study of light's properties and behaviors. We want to study how sort of light travels, how it's created, and sort of especially what happens it hits different surfaces. So we've seen in the previous slides that refraction happens when it hits sort of a different medium. When we talked about kaleidoscopes, um, we saw that it creates those patterns by true reflection. And that's what we want to study is how it happens to light when when it hits a surface and it gets reflected, refracted, or sort of absorbed. And in optics, scientists ask sort of those questions such as, why is the sky blue? Why do magnifying glasses make things look bigger when you point it to an object? And sort of how does lasers work? Um, all optical scientists sort of work in sort of that sort of area. And one of the things that they look at is sort of lenses. So lenses is sort of a piece of glass or sort of a very see-through material, but it's really curved on really both or one side. And it's normally shaped like a circle. So that's why you sort of think about it as sort of cameras, as you can see over here. And they can help make things look bigger or smaller than what we see in real life. So can anyone think about any examples of where lenses can be used? I know Nathan and Jason said cameras, cameras, yep, that helps us sort of see things a bit better. That's sort of more of a mirror. Lenses are sort of a different thing. Mirrors more or less reflect things. Lenses, on the other hand, use refraction a bit more. Pinhole cameras is sort of an early camera device, and we're actually going to be looking into that. So hold on to your question, and I'll try to explain it a bit more. But lenses could be things such as being used in cameras. It could be sort of microscopes are a good example. Binoculars, telescopes, anything that helps us sort of focus or diverge light. And we'll talk about what focusing and diverging light is and the different kinds of lenses that help convey that. So the first thing we're going to look at is sort of a convex lens. So it's this sort of lens over here that's sort of thicker in the middle and sort of thinner as you go to the edges. So these are sort of the light rays over here, pointing towards the lens. Does anyone know what will happen? So what do you think will happen when the light rays hit the lens? Where do you think the light will go out afterwards? Yes, Pratik.
My name is Prapti and it'll reflect the light back.
That's a good hypothesis, but this is a lens. So with lenses, they will sort of do a sort of refraction. If this was a mirror, it would definitely reflect backwards. But for sort of lenses, it would try to pass through it and go somewhere. And where do you think where do you think the light would go? Would it go away from the lens, or would you think the light would go towards sort of a point? To give you a clue, convex lens is sort of a converging lens. Does anyone know what converging is? Yeah. So converging means coming together. So with that sort of clue, does anyone know how the light would refract here? Oh, I'll repeat what I said. So converging means things are coming together. So convex lens, another term for that is sort of converging. It's a converging lens. So with that in mind, anyone has any guesses as to what happens when the light hits that sort of lens? Yep, it would definitely come together. So as you can see here, as I said before, converging lens sort of focuses light rays to a very specific point. It's very thicker in the middle and sort of thinner around the edges. So as you can see on the top and bottom, as light passes through the convex lens, it sort of refracts and bends towards the other light rays. So it goes all together at one point and meets one point. and then it spreads around later on. But it focuses on our point, so that way we're able to see sort of an image. And where you might see a convex lens is sort of in like a magnifying glass that helps us focus things and makes it look bigger. You can also particularly use convex lenses if you have eyeglasses. So if you're sort of long-sighted, you can't see from things from far away, you would probably use a convex lens to help you see things more clearly. And the reason that the light rays sort of bend or refract at different angles or different directions is because of how the convex lens is sort of shaped. It's more, they're going through different thick. You can see that as it's going thinner and thinner towards the end, there's less material for the light to travel to. So it will be bending at different directions, at different angles. But one thing to note is if a light ray is sort of traveling straight through a convex lens or any kind of lens, it would just travel straight through. And that's sort of a law that we have in physics, is if a light ray just passes through straight through a lens, it would just go directly there. But in different directions, such as the top or bottom, it would sort of refract in different directions. And with a convex lens, these light rays would come together. And that's sort of another example to highlight how a light ray sort of reacts when it passes through a converging lens. So now we also have a concave lens. I'll give you a clue. This is sort of the opposite of a convex lens. So as you can see over here, it's sort of thicker in the top and bottom, but very thin towards the middle. So does anyone have sort of a guess or a theory as to what might happen? It's still a lens, so it will sort of do the refraction. Yep, Nathan and Jason say they'll go apart. Concave lens is also known as sort of a diverging lens. So diverging means spreading away. So as you can see over here, as the light rays hit the lens here, the light rays are spreading away from each other and moving away from the lens itself and from the other light rays. And to sort of see where it could be sort of used, concave lenses are used in sort of spy hole or keyhole on doors, so that, you know, those tiny keyholes on doors, so that way you can see who's knocking on your door before answering it. That's where concave lenses are playing a role. And it also helps people who wear eyeglasses and are sort of short-sighted, so who can't see from short distance. So like my glasses are sort of made with concave lenses, and that helps me see things more clearly from a short distance. Both concave and convex lenses can be used together, and that can create different sort of illusions or diagrams about how light rays are going to move or from one way or another. We won't talk about that in this lesson here, but that's something for you to note. Normally, we just don't use one type of concave or convex lens when trying to create like a telescope, for example. We use a different series of it, different sizes, shapes, thicknesses, all play a role in trying to get a good image of what we're looking at. And that is especially important and true when you're doing sort of telescopes, for example, or binoculars. And that's sort of another example. It's not very clear over here in this image, but you can see that the light rays at one end, at the other end of the concave lens is spreading out a bit more. And as in this session, we're going to be talking a lot about cameras. So cameras are these sort of optical instruments to capture still images. And they can nowadays be stored either digitally, but in the past, they've been using film in order to create like a physical image of what you've captured. And we can see different cameras that have been created throughout the years. So the first image on the top left is sort of the first earlier cameras that were created. They're really large, really loud, really hard to use. And they used film in order to create the image once it's captured. And in the past, the way that people created film was very dangerous. They used a lot of dangerous chemicals and did a lot of dangerous chemical reactions in order to create the image that has been captured from this camera. Nowadays, as engineers, we try to make it a lot more safer to take pictures. And another way that a camera uses film to take pictures is sort of this sort of instant camera. I'm not sure if you've seen this before. This was very popular like around 20 years ago. So it's similar to this camera over here, but it's much more smaller. So you can actually take it anywhere you want to go. And it's really just powered by this film that acts as a sort of battery, but also as a way to store the images that you've captured. So once it's full, usually you would take this camera and the film to like a Photoshop, and people there, the specialists over there, would try to take the film and use more safer chemicals and sort of in a very dark room to sort of print and see how print and take that sort of film and print out like a large scale photo of what you have. And throughout, another way to see that instantly was this sort of Polaroid camera over here. So it had film sort of on the bottom here. It's sort of another instant camera. When you take a photo, it immediately prints out the photo right in front of you. A lot of people still use these today. It's a fun way to have photos that are not captured digitally. And it's a fun memento. It's really safe to use, although a bit expensive. And but nowadays, a lot of people are sort of using like these really large cameras. Like photographers use these cameras with large lenses, as you can see over here, to capture photos from like a far distance to get a very crisp, clear photo. Yeah, people can use these on trips to just keep mementos of it. And nowadays, most of the time when people think of cameras, people really just think about their phones and the cameras that they have on here. Cameras are getting smaller and smaller throughout as we learn more about technology, as we engineer things, test and evaluate, and create newer and better versions of it while keeping it more portable or smaller. But there are different types of cameras that are still being used today. But the main features of sort of a camera that you should probably be looking out for is sort of the box. So the box basically means the body of that camera. It houses sort of the main components of the camera, where to click, where to see things. It controls all the settings that a camera might have, such as lighting, exposure, stuff like that. It houses a lot of those inner components that you are used to make the cameras work as they do today. And sort of a very important part of a camera is maybe the lens itself. So as you can see from our previous lessons, previous slides, we use camera lenses to sort of refract light and sort of concentrate it and direct it to the camera. So that way we're capturing that image. And this is very important, and the quality of these lenses is really important to consider, as that affects how crisp or how good of a quality our photos come out once we print it or see it digitally. And another important feature of a camera is sort of aperture. So it's part of the camera lens actually, and it really just controls the amount of light that passes through the lens. And it's important to make sure that your photos are not sort of overexposed, meaning that when you see the picture, it's not just a lot of light and you can't really see like your object or your face if you're taking a picture of it. It sort of controls that aspect. Um, make sure that cameras are able to take the picture and be able to control the light, making sure that the object that you're seeing is sort of visible in your print or film. And as I said before, engineers play a huge role in the development of camera from the earliest times, from it making sure that the chemicals are safe to use in order to print the image, or just making it digital and making it portable for us to use. And I know someone had a question on what pinhole cameras are, and that's sort of the activity that we're going to be doing today is we're going to be creating a pinhole camera. And pinhole cameras are sort of the first or earliest source of cameras developed. One big thing about a pinhole camera is that it doesn't really use a lens here. It has a very tiny aperture or something that controls light. And it's this tiny pinhole that directs light into the body of that camera or the box. So when you have an image over here, it has sort of this candle, it has light on it, and those light rays go towards whatever direction or surface it can go through. And if you're pointing sort of your camera over here with just that tiny small hole to let light in, light will just enter through that hole. And as we learned before, light does travel in sort of those straight lines. So as a light ray passes from one way into the hole, it goes in sort of it continues to its direction that it went through. So if it's going down here, as it enters through the hole, it just keeps going straight down. Going straight, it keeps going straight into the hole. If the light ray is coming from above into the hole, it goes straight up. And that's how it happens. And that's how this image is sort of formed. So in a pinhole camera, the image that you get is sort of inverted. And this is sort of a phenomenon called camera obscura. And this sort of phenomenon occurs because of how light rays are and its properties as it travels in straight lines. So it will project your image, but it will project it in an opposite direction. Normally, on this side is where you're viewing. On the other side of the tiny hole is where you view sort of the image that you have. This is more, normally this is sort of like a very opaque or not transparent, but not dark or clear enough, just so that you're able to see or project that image in front of you. His people in the past, usually once they take the picture or capture the object that they want to see, they usually try to draw it out from the projection there. And that's how they would probably use the pinhole camera. They would try to draw that image out because film wasn't created at that time before, and they didn't have a means to digitally store it in the past. People still use pinhole cameras still today. Mostly people do use it to track the movement of the sun. So it can, so if you have like a solar eclipse or something like that, a pinhole camera is one way to sort of view a eclipse and see how sort of the sun moves throughout the day. And the reason that pinhole cameras are allowed to do that is because they sort of have that very infinite depth of field. So it can capture a lot of images. Everything can sort of appear on focus, even if it's far away. And that's what pinhole cameras are sort of used in sort of viewing or moving or tracking the sun. The only sort of downsides of using a pinhole camera is that, yeah, there isn't a way for you to sort of capture the image except by drawing it out. And it's really hard to capture very fast moving objects. The sun moves, we see the sun moving very slowly around us, even though it's sort of moving a bit fast, but it allows the pinhole camera to track it easily. But if you're like trying to capture like a fast moving car, for example, that's racing around a racetrack, maybe a pinhole camera might not be useful. There are pros and cons to it, but I think pinhole cameras are really cool or fun to play around with. Does anyone have any questions about what pinhole cameras are? Or are you guys good to go? Thumbs up in the chat, or you do, maybe Jason, you understand the pinhole cameras? Practically good. Okay, if anyone has any questions about pinhole cameras or lenses that or refraction that we've learned, is there a way to refract light? Can you explain your question, Nathan Jason? Through a pinhole camera, is that your question? So the image appears normal and not flipped. With a pinhole camera, that isn't really possible as there isn't really a lens around here. You'll learn in sort of maybe in later grades, especially in high school, um, when you look at like concave or convex lenses, the way you position the lens to the object that you're seeing really affects how the object is going to be seen as. It can be seen flipped or it can be seen as upright. And there's just sort of different optical phenomena that occur that leads to those sort of things. If you have sort of your if your phone or camera takes photos and it sort of gets it inverted, normally sort of computer engineers try to flip it over so that way you're seeing your image upright. Yes, pinhole cameras don't have a lens. It's just a tiny hole here. Lenses were not really created or invented at that time. This is what Bob, I think pinhole cameras were invented around 200 or 300 years ago. Um, well, pinhole cameras are sort of more of an inexpensive portable camera. It's just an easy way to capture images if you wanted to. It comes from the word pinhole here. We could put a lens there. It would change the way the camera would work. At that point, you may want to build a more realistic or more detailed camera that can capture the object. And lenses, like I said, are kind of expensive and really require a lot of understanding of how lenses work. And engineers try to create the perfect lens for the camera to capture that image. But for a pinhole camera, it's just using that sort of pinhole as a way to enter light. So we'll get into the activity that we have for today. So we are gonna help a film producer capture a film set, and we'll be using sort of a pinhole camera. These are sort of examples of a pinhole camera in real life. Someone used like an old new digital camera and flipped it to make it into a pinhole camera. You can probably see this tiny screen here that sort of is the hole and that allows us light to enter through it. And this is sort of a very similar version of the diagram in the previous slide. It's just a box over here and light enters through one hole and allows the image to be viewed there. So this is our problem that we're going to be doing today. So we're going to be making a pinhole camera. So I'll get you some time to collect the supplies you need. Let me just get the camera here. So what you need for today's activity is sort of a ruler to measure stuff, a really sharp pencil. You could get a pencil, get a sharpener, try to sharpen it a bit more, and that could help. Or if you have a pen, you can use that as well. But I do recommend a pencil just so that way it's more safer for you guys to use. Another thing that we need to use is sort of wax paper, and we'll talk about why we would be using sort of this sort of type of paper. So this is probably in maybe in your kitchen. Wax paper is mostly used for baking purposes, and we'll be using this today. We have tape. Alternative for wax paper, you could use sort of parchment paper, baking paper. That's an alternative to wax paper. The reason that we use sort of wax paper in general is it's not as sort of, it's not sort of not clear as compared to like regular paper. So with, I don't know if you can see it here, it's sort of opaque. So it's not transparent, but it's not dark enough where you can't see sort of my fingers through it. Yeah, it's translucent. That's the word I was looking for. And that's why we would want to use wax paper is so that we can view the image, and wax paper is used so that way you can draw your image that you get from your pinhole camera. That's what we recommend. You could try to use regular paper, but you will probably not get a very clear image of what you're looking for. You want something that's very translucent. Um, Scissors is something that's important to use. For a pinhole camera, it starts the image, but is there a way to view it? So if you want to view the image from a pinhole camera, it's just through, for example, the wax paper. And that's one way to see your image in real time. But if you want to store it, people would just will draw it out and maybe try to take the wax paper off and then replace it back into the pinhole camera. So that way they can take another image, view it, store it, the same process. We have tape, scissors, or maybe a box cutter in order to sort of create the lens or sort of the way to view the image. And the most important thing here is sort of the box. I have this big shoe box over here. You can use any kind of box that you have, as long as you're able to cover it and there are not really any holes around it. If there are holes in your box, you can maybe use tape and maybe paper to cover it up. Just make sure, because you want to make sure that the light entering to the box doesn't disperse anywhere else or move around. You want to make sure that the light enters your hole over here, you're able to see your image on the other end. I'll give you some time to maybe get your materials, maybe the next minute or two. But as people are gathering their materials, does anyone see the similarities between a pinhole camera and a film camera? Looking at sort of body, sort of lens, and sort of aperture. So the body is sort of the shoebox that we have over here. Yes, Prati.
Um, can I use like a different box? I don't have a shoe box.
Yeah, you can use a different box. What box do you have?
Um, I have I have like bigger boxes, like cardboard boxes, bigger than shoe boxes.
It can work. It's just a little bit, it's going to be you can probably use the cardboard box. It's just going to be a lot more, there's just going to be a lot more cutting. You just want to make sure that you are able to close your box fully. That way there's no light that is passing through.
Okay.
Yeah. So yeah, as I said, the body of a film camera is similar to the shoebox that we're going to be using here. The aperture, as we said for pinhole camera, is going to be the tiny hole that we create to the box. And the lens is going to be sort of the wax paper that we use in order to view the image as it's created. Does everyone have their materials ready? And yes, Ethan, Jason, film cameras are like pinhole cameras, but with bigger holes and lenses. That is correct. Pinhole cameras uses a very tiny hole in order to get the image that you want. Does everyone have their materials? Should we move on to the next stage?
I need some more time.
Okay. As you gather your materials, I'll maybe just talk about the next stage that we have before we go to the making the model stage. So designing the solution. So I have one prototype of my pinhole camera here. So important things to consider with designing a solution is sort of how large do you want that aperture to be? So how large do you want that pinhole to be? I would start off by creating a very small hole with your pencil and going and doing the engineering design process and trying to make it bigger gradually. I wouldn't want to create a big hole in the beginning because if you do create a big hole and poke the entire pencil through the box, then there isn't a way for you to recreate your prototype if you want to make the hole smaller in the end. So I would start off by trying to create a small hole and then test it out, see what happens, and then gradually make the hole bigger. how big you want your image to capture, how big do you want your captured image? So thinking about your wax paper and how big you want that lens to be, how big do you want that image to be formed? And this might be dependent, it may depend on the box that you have over here. You want to create a whole, large hole that captures the image as big as possible, but you want to also be mindful about the box that you have. That could be sort of a limit. And in terms of testing and sort of thinking about how testing would work, thinking about where you would, what image do you want to sort of project? So taking how far that object is and how much light is sort of available around it. These are sort of things you want to keep thinking about as an engineer and as we go through the engineering design process. Okay, I'll maybe start off with making the model itself. If people are still gathering materials, that's okay, but in respect of time, we'll maybe try to get the model going. So I have my box, empty box over here, and I want to create one hole onto the box. So if you have a shoebox like me, you want to create the hole on the shorter end of the box here, not on the long end. And that's because we want to get as much light that travels through the box as possible in order to form an image. And that allows us to get a greater view or sort of view of the object that we're going to be seeing once we do our testing phase. So try to create a hole in the middle. One way that I like to do sort of a tip if I want to find the middle is sort of use your ruler and try to create an X across the box. So that way, once you find the point that the box intersects, just give me 1 second while I try here. If you draw a line over here and find the spot where both lines meet, that's a good sort of estimate as to where the middle is. So I would try to do it as slowly as possible and try to get the line on top over here. I don't know if you can see it in here, but I did draw sorry. I did draw a X around the box on this side in order to mark a sort of point here where I would want to put punch a hole into the box. Does anyone know how, does everyone understand that? Do you want me to repeat what I've said? Feel free to ask questions. Feel free to raise your hand. I'm going to be trying to poke a small hole onto my box. So I want this hole to be as small as possible for now. So I just try to take the tip of my pencil and just poke a hole until the lead stops from the pencil. So just a very, very tiny hole. And then maybe in later stages, I'll try to create a bigger hole. So I don't know if you're able to see that, but I created one tiny hole over here. Has everyone created a hole into their box, or does anyone have any questions? Or can we move on to the next page? Thumbs up, say yes in the chat, or if you have questions, feel free to ask me. I don't see any questions. I can move on to the next step, and we can go back to the previous steps if we need to. So if we created a hole on one end of the box, we need to create sort of the sort of a square where we're going to put our wax paper and view our sort of image. This is where we're going to place our eye and sort of see where the image is going to be formed in. So if we have a hole in one end of here, we'll probably be looking at the other side of it in order to create sort of a square. It doesn't have to be 2 inches or about 5 centimeters around the sides. This will probably depend on the box that you have. You can, if you have a smaller box than this, then I would probably make it maybe around 3 centimeters, 3 centimeters square all around, maybe smaller than that if you have a smaller box. 2 inches or about 5 centimeters should probably fit my box. So that's what I'm going to be doing with this, with my prototype. And ideally, you would want to create sort of you want to create your square that sort of, it makes sure that it's also in the middle. So that way, once your light passes through the tiny hole, it directly goes to the middle of the other side and allows you to view the image. Does that sort of make sense? Does anyone have any questions, concerns? Feel free to use the chat. Let me know where you're at. That way I have a good sense of how I can help you and sort of give you any tips or pointers if you're a bit lost. Feel free to ask me those questions. Or if you have questions about pinhole cameras, just let me know. So similar to the first step, I also created sort of an X around this box. So that way it helps guide me where the middle is. And that way I can create a perfect square right in the middle of the box. If I have my ruler over here, I could try to measure out maybe 5 to 6 inches on the middle itself and try to create a perfect square that goes around. Is everyone in step 2? Is everyone cutting their square out? Does anyone have any questions? Or did I lose you all in certain stages? Feel free to let me know if you want me to go slower or faster. I'm here to help. So I created a sort of, okay, Nathan, Jason, that's totally fine. I would try to create that square, try to create an outline of the square that you want to cut out. So I don't know if you can see it over here on my screen here. I have a square that I outlined with a pencil, and that's what I want to cut it. What material do we make the square from? Oh, you're not making a square out of things, you're cutting a square out of the box. So you're taking your shoe box and you're cutting a square right in the middle on the opposite side, as you can see in the image over here. This person has created already a square on the box, and that's what we want to create. And so I'll just start cutting things, but feel free to ask further questions. I'm using a box cutter. I could use scissors, but my scissors are a bit blunt right now. If you're using box cutters, I would try to ask parental supervision. Even with just using scissors, I would probably try to ask your parent to be around just to monitor and supervise you, just to make sure you're safe when using it. My box is a bit harder than a regular shoe box, so I'm going to use a box cutter as that's probably going to be a bit easier for me to cut things out. I'm just going to take maybe a minute or two just cutting this, but feel free to ask questions as I cut things out. This is a cool pinhole camera. It's not the most perfect square, but it's a good estimate as you want to make a rough prototype of your model. Is everyone cutting their square out? Anyone have any questions? If you don't have your materials available on hand, that's totally okay. The video is going to be posted on our YouTube live channel, and I do encourage you to follow the activity in your own time, just so that you're able to understand how pinhole cameras work, as it might be a bit tricky to understand how that image is sort of inverted once you use your camera to view an object. So it's really important to create your prototype. It helps in your learning, and it's a really fun project. It's a good activity to play around with. And you have a camera that you could probably use for your next solar eclipse, which I'm not sure when will happen, but it will probably happen soon in our lifetime. Okay. Everyone have sort of as, so this is what I have so far. It's this square. Uh, it's an empty square that I could probably put my wax paper on top of. If I close it, that's what's gonna happen. So light is gonna go.
Excuse me. What are we making? For a few minutes, it just went on mute and then I couldn't hear anything.
We're making a pinhole camera. So we learned about what
Huh?
we're making a pinhole camera. Sorry, Im, I think you're on mute. I wasn't able to hear what you said. We've learned what pinhole cameras are. They use a tiny hole to capture light and view an image on one end.
Okay, so what are we supposed to do?
So we are
Like have a box and then cut it?
yeah, so we're having a box.
Okay,
And a cut square on the side.
so like we take a box and then cut it.
Yeah, we cut a square.
Because, so can this do? Because I got new pairs of shoes yesterday, so will this do?
Yep, that can work. You just want to cover
Okay.
the holes around it so that way it just lights
And then cut a square on it, okay? Like that?
Scissors don't work, Nathan and Jason. And we don't have a box cutter right now. That's all right. Scissors can be a bit blunt, especially if you've used them a lot for several different art projects or stuff like that.
Okay, then we cut a square.
Yeah, a square. I would cut, Nathan and Jason, I would try to cut these. It may be a slower process if you use scissors, but it would work. Just might take a little bit more time. It will probably make your square a bit more cleaner than what you use.
Okay.
But if you don't have it, maybe you can ask your parents to get you a box cutter or maybe assist you in different ways to cut that square off. In the interest of time, I know there's around 2 minutes left, so I do want to get through the next stages and have you see what the next stages are. You guys can watch what I'm doing and maybe in your own time, you can follow the steps over again. So I'm gonna take some wax paper over here and I'm gonna try to cut it so that way I can put it on top of the sort of shoebox or the pinhole camera. So you could just tape it over. I would try to maybe use scissors and create a square. It just needs to be a little bit bigger than the square that we've created. So that way you can put it on top. So I have one tiny rough square that I've created. And I'm just gonna put it on top of my box over here with tape. And from here, you can probably see that once you have light pass through the box, an image is able to be formed onto it. So I'm just gonna tape it a little bit here just for you guys to see it. Bear with me. Does anyone have any questions, concerns? Apologize if we're still doing the prototype. I know it's 10 past 10. The live stream is still going and I'm gonna continue live streaming until we reach the test and evaluate phase. So you guys can stick around, but if you do need to leave, that's totally all right. Thank you for joining us. And you can view the end of the live stream toward on our YouTube channel and I'll send an email reminder for that. But feel free to stick around if you have time. Bye, Shauna. Bye, Preppy. For those who are staying here, feel free to follow along. If you have any questions, feel free to ask me. So I do have my sort of wax paper that's placed on top of the square that I've cut. And I already have my pinhole on the other side. And that's sort of how the model works. Place the square of wax paper over the square you cut out. I would try to tape the wax paper over the edges, as you don't want any of the tape to go around it. So that way you can see your image here, especially if you don't have like clear tape that like I have. You just want to tape it around the sides. And that's why we ask you to create a square of wax paper that's larger than the square of the box. And this is sort of our test and evaluate phase. So this is the prototype. This parchment paper work. Parchment paper should work. It has very similar properties as sort of wax paper. It's sort of translucent and it should be able to work. Wax paper is probably the best as it does have a more translucent like appearance to it. You can try parchment paper. You can try different kinds of paper onto your pinhole camera and maybe test it out and see what kind of image quality you get. So instead of using sort of wax paper over here, try parchment paper. If it didn't work out, if your image didn't look well, that's sort of part of our test and evaluate phase, right? So instead of parchment paper, I maybe want to try out using wax paper. And what's easy about the pinhole camera is that it's just taped onto the box, right? So you can just take it off and put in your next set of paper on top of it and test it out. And you have a new model of your prototype. So the way, if you want to test or evaluate this is sort of, if you have an object that's sort of far away, I would try to get a blanket and cover myself up, cover you and maybe half of the pinhole camera, and try to guide it to where the light is and where the object that you're looking at is. So in this example, we're looking at sort of a lamp object over here. And we want to point our camera to the direction of the light. So what we're pointing towards us is sort of the wax paper sort of square that we created. That's sort of our viewing side. And we want to try to point the pinhole or the hole that we've created onto the image onto the object that we're trying to view. So in this case, it's going to be the lamp. You want to do it in a very dark room as you want just the light from the object directly going to the pinhole camera. So that way you're able to view things. So that's why in solar eclipse, everything is dark around us. And that's why a lot of people in astronomy use maybe pinhole cameras to like view the sun and how it moves through a solar eclipse. This is sort of a prototype that I've done. So I have two prototypes of my pinhole camera, both the same sort of box, sort of same style. As you can see here, this is sort of the object that I'm trying to view. This was the square that I created and there's wax paper on top. And then there's a tiny hole that I created. And this is sort of a blurry image of the image that I found from my pinhole camera. So I covered myself up with my blanket. As you can see over here, you can see the blanket on the edges. And you can see the image that I got out of it from viewing it from the pinhole camera. So you can see that camera obscura, the phenomenon occurs over here. So you can see it's upright and the image, the lamp here is upright. And the image formed over here is sort of upside down. And that's because of how light travels through the box. It's a really cool phenomenon. And if I wanted to trace it out, I would try to draw it around the edges here and try to capture the image that I've created. And like I said before, people use this to watch a solar eclipse. So people would try to watch the movements by drawing out or tracing out where the sun moves at different stages of time. They would just hold the camera on directly towards the sun and try to monitor it and make a few notes around your wax paper just to see where the sun is moving or which direction it's going to go into. This is sort of the test and evaluate stage again. If you do create your prototype, I encourage you to test it out a bit more. Like I said, if you don't have parchment wax paper, try out different types of paper and see how the image quality is affected. As I said, try to start off with a small hole and make bigger holes towards the end and see what happens. So when you create a bigger hole, more light is entering towards it. And when more light enters towards the camera box, see what phenomenon we get. Would you have a brighter image? Would you have a darker image? That's sort of another theory or thing that you want to test out. And that's part of the engineering design process, is when you have one theory or one question that you want to think about and you have an answer to it, what can you do with that answer? So if I want to make the hole bigger, what do you think I could get out of it? And that changing the size of the hole can affect the quality of the image over here as well. So I encourage you to slowly make that hole a bit larger than the previous model and see how it affects the image that you get from the pinhole camera. If you can trace out your image and send it to us, I would love to see how you guys created or see what objects you've used to view your view it with the pinhole camera. Does anyone have any questions, concerns? We are towards the end of our session, and so thank you so much for joining us. And I know it's 7:10, so I appreciate you guys staying in for this call and seeing how the entire pinhole camera was created. We learned about lenses today, convex, concave, and how light is refracted through those lenses. Learned about lighting, how it's important in the entertainment industry by Nathan and Jason. And we learned how pinhole cameras work. And I hope you guys have a great rest of your day. I'll stick around if you have any questions. But I'm ending the live stream right now. You guys can turn on your cameras. I'll be around if you're still